How long was your walk to get to school?
I didn't walk. Rode the bus.
Ooh, yeah, money right there. Miss Fred, can you put the heat on a little bit? I got chills.
I don't have any. All right.
You don't?
Here we go. Today we are going to talk a little bit about sequences and series, actually sequences today. So let me give you an example of a couple of sequences. Okay, so here are a couple of sequences. This is in your notes, same notes as before. It's a continuation of your old notes. Your chapter 9 notes, I should say. There's only 2 sections in this little unit, so we won't have a full-fledged test. We'll have like a class over this, and then we'll move into chapter 8. And then that's it. Okay? So, here we go. Can you tell me what would come next in this sequence right here? If you had to continue this, what would come next? 14. And why would 14 come next? Because you are adding 3 each time. You've seen that pattern. This kind of a sequence is called arithmetic. An arithmetic sequence, and I know the word looks like arithmetic. When it's a noun, we say arithmetic. When it's an adjective, we say arithmetic. This is an arithmetic sequence because we get from term to term by adding the same number. In this particular example, that same number is 3, but it doesn't have to be. It could be anything. You can make a sequence with anything. The same number has a name. It's called the common difference. And it's called the common difference because if you do 11 minus 8, difference, subtract. If you do 11 minus 8, 8 minus 5, 5 minus 2, it's the same number. It is a common number. Okay, so what's an arithmetic sequence? You get from term to term by adding the same number. Is this one arithmetic? No, because here we are getting from term to term by multiplying. So this is called a geometric sequence, and we get from term to term by multiplying by the same number. And that same number is called the common ratio. So here in a little bit, we're going to look at some sequences, and you are going to determine if they are arithmetic, geometric, or neither. And how will you know if they are arithmetic? You're going to go from term to term by adding the same number. And how will you know if they are geometric? You go from term to term by multiplying by the same number. So what happens if you don't do either? Well, then it's not arithmetic or geometric, and you can have sequences of numbers like that. All right, everybody good with your definitions? Here we go. Number 1A. What do you think about number 1A? Geometric. What are we multiplying by? We're not multiplying by 2. We're multiplying by 1/2. We're actually dividing by 2, which is multiplying by 1/2. So it's geometric, and R, the common ratio, is 1/2. So go ahead and write that down. Geometric, R, which is the common ratio, R is 1/2. Okay, what about B? What's happening in problem B? Arithmetic, and the common difference, D, the common difference is what? What are you adding? 10. So it's arithmetic, and the difference is 10. D is 10. How about C? Arithmetic, and the difference is, what are you adding? 8. The difference is 8. How about D? Neither. Now, is there a pattern? Do you see a pattern in D? Could you continue the sequence? I think probably. You start out by adding 2, and then you add 4, and then you add 6. So the next term, I would just add 8, right? But since I'm not adding the same number, it's not arithmetic. There's a pattern, I can figure it out, but it's not arithmetic. All right, how about E? Geometric, and the ratio is the number you're multiplying by, and it is 2. How about F? Arithmetic, and the difference is 2. And finally, how about G? I think you can probably figure out what's going on there. But you're not adding the same number, and you're not multiplying the same number, so therefore it is neither. Anybody recognize those numbers? What are 1, 4, 9, 16, 25? Those are the squares. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So the next number would be 36 and 49.
So you're
Okay, all right. Next, find the first 4 terms and the 70th term. So this is very easy, but there's some wild notation involved, so we need to figure that out. So this is like the rule for the sequence. When it says find B sub 1, you're just putting a 1 in for the n, B sub n, B sub 1. And if you put a 1 in for the n, what is that going to end up equaling? 6 over 1, which is just 6. And then it says find B sub 2. Okay, what would B sub 2 be? 6 over 2, which is 3. B sub 3, I'm going all the way. Alright, so B sub 3 would be 2. You see what I'm doing here, guys? A lot of you are kind of half asleep here. B sub 4 would be B sub 4 will be 6 over 4, 3 halves. And we don't have to keep going. We can skip. If for some reason you want to know what B sub 70 is, we can skip to it. What's B sub 70? 6 over 70, which is 3/35. This is called the general rule for the sequence. You can find whatever term you want. This is the first term, second term, third term. You can find whatever term you want by just plugging in whatever it is, 100, 800, whatever you want. Number 3. For For the following arithmetic sequences, find the common difference, the eighth term, and the explicit rule for the nth term.
Do they have to
Oh
be?
wait, I skipped B, sorry.
Do they have to be in fractions or can they be in decimals?
As long as you're not rounding them off, they can be in decimals. Remember, if you have a decimal that goes on forever and ever, we use our math frac button.
Just for the 6/7, I got 0.0857.
Did it stop?
Yeah.
Yeah,
Okay.
that's fine, as long as it stops. All right, I forgot this one, you need to do this
No,
one,
I'm trying.
which I think you can.
I'll just skip it.
All right, so for problem B, we have a different rule, this is our rule. So what would C sub 1 be? This means the first
Plug in the
term.
1.
C sub 1, first term. What would that be?
2 times 1
2 times 1
plus 1.
plus 1, which is 3. What would C sub 2 be? The 2 in here, so 2 times 2 plus 1, so 5. You'll have a calculator for this whole unit also, just like before. C sub 3, 7, 2 times 3 plus 1, 7. I'm kind of seeing a pattern develop here, let's see. C sub 4, what would that be? 9. And then C sub 70, so we're gonna skip a whole bunch, it goes straight to 70, 141. Do you think that's pretty easy? Yeah. Okay. Now, let's look at the next one. In the directions, it says that the problem is arithmetic. If they hadn't told you that, would you be able to tell that that sequence is arithmetic? Yes, right? What is the common difference? What am I adding to get from term to term? -4. Now, some of you will think you're just subtracting 4, and that's true. But in terms of sequences, we only add or multiply. So it would be adding -4. All right, so my difference is -4. That was the first thing it asked me to find. Okay, now it says find the 8th term. A sub 8 means the 8th term. Well, what is one thing you could do to find the 8th term? Just write it out. Just keep subtracting 4. So this is the first term, second term, third term, fourth term. So if I just keep subtracting 4, this would be -13, -17, -21, and -25. Is that the 8th one?
Oh, we have to add -4 to keep
All right. Will that always work? Always. 100% of the time, that will work. You can always just keep writing it out. What is a potential drawback to that strategy, though? Yeah. What if this had been the 800th term? Now, could you still do this? Yeah, but it's going to take you forever. Exactly. There is a formula that works for arithmetic sequences. We're going to get several formulas in this little unit. You do not need to memorize the formulas, but you need to know. I'm going to list, like we take a quiz, I'm going to list all the formulas on the board, and you have to know which one to use, okay? So your arithmetic term formula. So in other words, if you want to find a term down the road of an arithmetic sequence, your formula is this. Now again, you do not have to memorize it, although after you use it a few times, you'll probably haven't memorized it. But you have to know how it works. So here's how it works. We wanted to find the 8th term, or the 800th term, or whatever term. So n is the term that we are finding. We want to find a sub 8. So n is 8. That means this n is going to be 8. Every n is 8 in the formula. What does this stand for? A sub 1 means the first term. And we know the first term is 3. What does D stand for? The common difference, which you have already figured out, is -4. So 3 minus 4 times 7 is 3 minus 28, which is indeed -25. Now, if you're only finding the 8th term of a simple little sequence, you might think it's easier just to work it all out, and I'm good with that. But if it's an 800th term, see, look, what if I wanted the 800th term of this sequence? I can find it really fast. It's 3 minus 4 times 799, 800 minus 1, and then I can just type that into my calculator. And it's -3,193. See how fast that was? It's easy. So when are we using this formula? When we are dealing with arithmetic sequences and we want to find a term. Okay. Now, the problem says, the same problem, it says find a formula for a sub n for this problem. Now, this is your formula for every every arithmetic sequence in the whole wide world. Okay, so this is like the big formula for everything. You want to narrow it down for just this problem. So let's look at this for a second. This means first term. In our problem, the first term is 3, so I can plug that in. This is the common difference. In our problem, it is -4. So to find your explicit formula, what we call the explicit formula, you just plug in the basics of your sequence. So the basics are the first term and the common difference. And then you simplify. So 3 minus 4n plus 4, distributing. So 7 minus 4n. There is your formula for this particular problem. How do I find the explicit formula? I use my general formula, the one that will be on the board, and I plug in my first term and my common difference. And then in this formula, you'll have to distribute and collect like terms, and that is your explicit formula. Let's try it again with B, the sequence in problem B. first of all, would you agree that it is arithmetic?
Yep. Yes.
Yeah. If it's arithmetic, it has a common difference. What is the common difference?
Minus 0.5.
Negative 0.5. We need to find the 8th term. So I could keep working it out. I'm going to use my formula this time. What does my formula say? If you want a sub 8, what are you going to start with? 10. Remember, this means first term. A sub 1. A sub 2 is second term. So start with 10, and then minus 0.5. Now remember, n is 8. So what will n minus 1 be? 7. So we have 10 minus 0.5. So it looks like your 8th term is 6.5. Again, you have a calculator to help you with all of your arithmetic. So what did I do? I put 10 right here because 10 is the first term. I put negative 0.5 here because negative 0.5 is my difference. And I put 8 here because I am finding the 8th term. This n and this n are the same. Alright, what about my explicit formula then? What will it be in this case? 10 minus 0.5 and minus 1. How do we find our explicit formula? We take our general formula and we plug in our first term and our common difference. So first term was 10, common difference is negative 0.5, and then you'll distribute and just clean it up. So it looks like our general formula, our explicit formula, is 10.5 minus 0.5n. Problem C is exactly the same. Take a minute with your partner and see if you can figure out the common difference, the 8th term, and the nth term of problem C.
Problem C? Alright, 10, 16, 22, 28, 16 plus 6. 16 plus 6. Okay, that's what we need. Okay, so E is the 6.
That's
And then
10 minus we have distributed.
that's that, I think. 2, 3, 4,
And minus
28,
and minus 1.
They need to stop.
Alright, what did you get for your common difference?
6.
6, beautiful. For your 8th term, and again, you can write it all out if you want, that's
54.
fine. I'm gonna go ahead and use my formula. The 8th term
Yeah, I get
would be
54.
10 plus 6 times 7?
That should answer my question.
Did you get 52? Was your eighth term 52?
Someone did that.
No, Ricky, I got 112, Mary got 52.
And then your explicit formula. 10 plus 6 times n minus 1. Remember, to find the explicit formula, we plug in this number and this number. And then clean it up. Did you get 6n plus 4? As your explicit formula.
Oh, yeah, that's it.
Does anybody have a question about that?
What was this?
No, 4 plus 6n, that would be fine. Alright, we good? Alright, next page, number 4. Again, we have arithmetic sequences, and your job is to find the first term and the 100th term. Alright, so we've got a sequence out there. And we know the fourth term is 13. This is a sub 4. Fifth, sixth, and the seventh term is 22. So remember, a sub 4 means fourth term. So I don't know what the rest of these numbers are, but I know the fourth one is 13, and the seventh one is 22.
God bless.
Your job is to find this term, that's the first term, and the 100th term. Clear out there, the 100th term. Anybody have any thoughts on this? What does arithmetic mean? I get from term to term by adding the same number, right? So if I look at this part of the sequence right here, the part I know about, the fourth term and the seventh term, I'm gonna add D again, and add D again to get from 13 to 22. Well, how far is it from 13 to 22? 9. And I'm adding 3 D's to get 9. So that means D must be 3. Look, if you add 3, you get 16, 19, 22. See how that works? It's very logical. I'm adding the same number 3 times and going 9. So those additions must be 3's. Now, if going that way, I was adding 3, what will I be doing going this way? So this one has to be 10, 7, 4. So my first term is 4. My common difference is 3. I can use my formula to find the 100th term. What will the 100th term look like? Well, my first term is 4. My difference is 3. And my n is 100. So this is 99. So the 100th term of that sequence is 300 and one. Very logical. All right, let's see if we can process this one. I know the third term is 8, and the 7th term is 36. I know it's arithmetic, so I'm getting from term to term by adding. So how many additions am I gonna make? 1, 2, 3, 4 additions? I'm going from the 3rd to the 7th, 4 additions. So 4 additions have to give me the total distance, which is what? What is this total distance here? 28. So each addition must be 7. And you can check that, because if you add 7, add 7, add 7, and add 7, you better end up with 36, right? And we do. So our common difference, the number we add, is 7. Now, if I'm adding 7 going that way, then I will be subtracting 7. So this number is a 1, and this is a -6. That's a big important number, because that is my first term. So do I want the 100th term again? Yep. So the 100th term will be -6 plus 7 times 99. Remember, the formula requires n minus 1. So that's 100 minus 1. So what is our 100th term? 687. All right, one more on the page. You and your partner try C. Same thing.
Talk to your partner.
Okay, I have to write it down.
Yeah. Because I don't really want to add.
Okay.
Probably because.
You're only moving through.
Is that really?
Oh,
Anybody have any thoughts?
Kaya's
You're doing this with both adding.
I'm gonna have to get from the 6th to the 9th, I'm gonna have to add 3 times, right? I'm gonna have to make 3 additions. So 3 additions are gonna make a total of what? How far is it from -1 to -10? -9, right? I'm backing up 9. So my difference is actually -3 this time, okay? So if I'm backing up 3, then this one would be -4, this one would be -7, that one would be -10, so it works out. If that way I'm subtracting 3, then this way I will be adding. So adding 3, adding 3, adding 3, adding 3, adding 3, 14. So my first term is 14. My common difference is -3. So my 100th term will be 14 minus 3 times 99. I don't know what that is, but we can figure that out easily enough. -283. Perfect. All right. Now finally, we've got some geometric sequences. So let's be clear on something. Bo, what are you doing on your iPad?
Got an update.
What the hell is that? What the hell is that in front of me?
Okay. Not doing that. All right. We can't use that formula for anything except arithmetic, okay? So if it's geometric, that will not work. Here's the one you use for geometric. Now don't be frightened by it. Again, you don't have to memorize it. A1 stands for the same thing it stood for before. First term. What do you think the R stands for? The common ratio, which every geometric sequence has one, so you're going to put in your R. And that N is the same as these N. So if you were finding A sub 100, N would be 100, and now the exponent would be 99. Okay, so let's see how this works. I have a sequence, 3, 6, 12, 24. Can you tell me the ratio? The ratio is what? 2. The ratio is 2. I'm multiplying by 2. Can you tell me the first term? I hope so. It's right there. And then we're going to find the 10th term. And the 10th term is going to come from our formula here. A sub 10. So N is 10. So A sub 10 will be 3 times 2 to the 9th. And if you type it in just like that, it'll all be good. So 3 times 2 raised to the 9th. You should get 1536. 1536. Everybody okay with that? That seems easy enough. All right, how about B? Now the sequence is 8, 1, 1, 8, 164. Now, even if they didn't tell you it was geometric, would you be able to figure that out? Yeah, because what's happening? What are we doing here? What is our R? We're multiplying by 1/8. Our ratio is 1/8. And our first term is 8. So our 10th term, using our formula, our geometric formula. The 10th term will be 8 times 1/8 to the 9th again. Did you get a little teensy tiny number? Did you notice it went into scientific notation? My calculator won't change that into a fraction. I could do it manually, but it's okay. If it comes up so small like that, you can just write 5.96 times 10 to the negative 8. Is that what you got? Is that okay with everybody? Geometric sequences get really big really fast or really small really fast, depending on what kind of a number you're multiplying by. If you're multiplying by 2, you're going to get really big really fast. If you're multiplying by an 8, you're going to get really small really fast.
Wait. You say you can put a decimal if it doesn't keep
Yeah,
going.
it's scientific notation.
So it stopped. It stopped. So can I write that one down?
No, it doesn't stop. It doesn't
It did?
stop. No.
Our Kaya's calculator stopped it.
Okay, well, it's all right.
Yeah,
Just
she
write
paid
down something
$1,000
like
for
that,
hers, so-
okay? Just write down something
Still
like
ticky.
that. All right, number 6, C, the last one. Let's do this one and then I want to show you something kind of cool.
Is that half?
All right, so here we go. Letter C. What is my ratio?
-3.
Oh, I'm
Negative
talking about
three.
it.
My first term is -6.
Just be quiet.
So the 10th term will be -6 times -3 to the 9th power. Is that okay with everybody? This is going to be a big number.
Can I please ask a question? I'm trying to figure out where you get the 9 from, and I just can't.
The exponent is n-1. So if n is 10, if n is 10,
Can you have your phone number?
-6, -3 to the 9th. Did you get 118,098?
How do you do your power now?
Now, before we go to the next section, because there's a little bit of difference there, before we go to that, I want to tell you a couple of quick stories that involve this kind of thing.
Like that at your body and popcorn.
So, most of you probably know, like Daniel, Michael, the Michael kids.
Who was that?
Okay. Their mom went to cathedral. I taught her a long time ago. She's really smart. That whole family is really smart. Daniel's mom is the sister of Mrs. Bradshaw's husband. They're all Bradshaws.
Family tree.
But yeah, and they're all really smart. So anyway, when she was a sophomore, actually, I had her in second year algebra. She came in one day and she said, "Mrs. Ford, my dad and I were watching TV, and they said something that can't possibly be true. And my dad and I were talking about, he said, let's just take it to school and see if the math teachers can figure it out." So here's what they said on the TV. If you took a standard checkerboard, and have you played checkers or chess, you know what I'm talking about, little squares on it. Okay, take a standard checkerboard, and you put one checker on the first square, 2 on the second, 4 on the third, 8, 16, and so on. So you can see what's happening here. What kind of sequence is this? Geometric, right? But as you keep going through the checkerboard, and every square, you put double what you put on the previous square. By the time you get to the last square, you will have enough checkers stacked there to reach the nearest star. And she's like, whoa. The sun is technically the nearest star, and it's, what, 9.3 times 10 to the 7th miles away? I mean, it's like forever away. She said, that just doesn't make sense. Okay, well, let's look at it. How many squares are there in a checkerboard, do you know? 64.
The fact that they were asking this
So
question-
we are really looking for how many checkers
Look at this
are
guy.
on the 64th square. Well, our formula tells us that on the 64th square, we would have 1 times 2 to the 63rd. Leilani, you see why that's 63 this time? Because it's 64 minus 1. Okay, well, let's type that in on our calculator. What is 2 to the 63rd?
60.
Whoa, that's a very big number. But remember, that's not a distance. That's how many checkers are on the board. So let's say you can get 3 checkers in an inch. I'm making that up, I really don't know. Let's just say 3 checkers make an inch. So divide that number by 3, and that will tell you how many inches you have. So if you divide that by 12, it will tell
We
you how
divide that
many
answer by 12?
feet you have. And then if you divide by 5,280, it will tell you how many miles of checkers you have. And it is that many miles of checkers. Now remember, the sun was only 10 to the 7th. This is 10 to the 13th. Isn't that amazing?
Kai is,
Absolutely amazing. So, being a math teacher, I'm aware of this kind of thing.
Right.
Geometric sequences grow
Said
like
divide by
crazy.
12.
That's what I did.
So in my first year of teaching, and I know you guys can't even imagine it,
12.
but yeah, there was a
Yeah,
time
she
when
said
I was
12, right?
100 years old,
Yeah, 12.
brand new,
That should be your
had
answer.
no idea what I was doing.
Oh.
And they gave me a class,
It's just,
back in the day, we called it
Can you say the right
general,
answer?
but it was like
it's 2 or
CP.
12.
37 students,
you're not doing the parentheses.
That's what I did.
37,
Divide the answer by 12.
all 4 grades, Algebra 1.
Why are you dividing?
So
Divided by
the
3.
class was primarily freshmen, had a bunch of sophomores, because when I first came to Cathedral, the graduation requirement was 2 years of math and pre-algebra counted. So you took pre-algebra and algebra 1, and then you could be done, unless you were going to college. But you could be done as far as Cleveland went. So I had a bunch of sophomores who were taking pre-algebra and I was taking algebra 1. Had a couple juniors who had failed and were retaking the class, and had a senior who had failed and was retaking the class. So I have this wild group. I'm brand new. I have no idea what I'm doing. You know, I come in, I'm going to change the world. I'm going to inspire lives. You know, all that stuff that you
You did
think
that.
when you're a brand new teacher. And they were brutal. There was this, and I came from the farm. I came from a very conservative, old-fashioned school. So my only experience was what I had been when I was in high school. And so when kids got in trouble in my high school classes, the teachers made them do things. Like you had to go, if you were chewing gum, you stuck the gum on the wall and then you had to put your nose in it. You
Oh,
stood
heck.
there. If you were bad, you had to do push-ups or some kind of physical thing. So I had this kid, and I know it to this day, and he calls me Sarge, because I was, but we have a good relationship, great kid. But he was a typical sophomore boy, and he tested me every single day. And so finally, okay, so my punishment was, okay, you're bad, 10 push-ups. Well, he was a wrestler, a really good wrestler, and he was purposefully doing bad things so that he could do his one-handed push-ups, and he had his feet up on the shelf, and, you know, just doing all, I'm done. Okay, so here's what we're gonna do. I called his mom, we didn't have email back then. I called his mom, she came in, we did, it was emailed dean of students at the time, she was there, and the kid and I came, and I drew up a contract. And here were the terms of the contract. You, because of your age, you must come to school, that's law, you will be in class. But you don't have to do anything. You don't have to do any homework, you don't have to take any tests, you have to be quiet, so you're not disrupting the other kids. But you can sleep, you gotta come to class, but you can just sleep, I don't care. But then, every day, after school, you will come back and you will do some push-ups. First day, you'll do 1 push-up. Second day, you'll do 2 push-ups. Third day, you'll do 4. Next day, you'll do 8. And we just kept going like that.
What do you stop at?
And the mom is like, this doesn't sound right to me. And I said, trust me, it'll be fine. The dean says, you really want to do this? I said, yes. And so as long as he was doing his push-ups, my end of the bargain was, hey, you're going to get an A in this class. You don't have to do a thing. You're going to get an A. But as soon as you can't do the push-ups anymore, then you have to behave like a normal, regular student. No more screwing around, doing your assignments, learning the material and what. Now, I'm not necessarily proud of it, although I was desperate at that point. It was survival of the fittest at that point. But I knew something he didn't, and that is what happens to this sequence. It gets really big, really fast. So on the 10th day, for example, on the 10th day, he is doing 512 push-ups. And that's only the 10th day. So it grew really, really fast. In his defense, it wasn't long and he couldn't do the push-ups anymore. And he was good to school the rest of the year, ended up becoming a successful person. It all worked out. But my point of these 2 examples is they're real life examples of how fast geometric sequences grow.
That was a great life story.
That was a life story. Okay.
I hope that motivates
All
Kaya
right, so
to
I'm
be
gonna
quiet.
stop right there.
That should motivate Kaya to shut up.
No, she's not the problem.
Yes, she. Oh my God.